Okay. So today we're gonna start with a new unit, a new subject, and a new topic.
New
And
topic.
you might see the picture and the title that it's the breaking point. It sounds
Mhm.
like the TV series Breaking Bad. But this breaking point, if you look at the picture, it makes
Mhm.
reference when something bad happens, but there's still a chance, there's still a little opportunity to do it great, to do it
Uh,
well. Okay.
okay.
Um, in this case, the rope that we have in here, you might see that the rope is almost cut, almost
Uh-huh.
separated, but there's a
Uh-huh.
little string in the middle that in this case joins it together.
Mhm.
So the breaking point makes a little bit difference to this one. Okay.
Okay, okay. Breaking point. Yes.
hmm So during this unit, oh, let me go again. Oh, there it is. So during this unit, the content that we'll be working will be divided in four. The first subject, it's describing types of technical problems. You all know, and we all know technical problems, like when the printer doesn't want to print, when the computer fixes
Mm-hmm.
down,
Okay.
etc. We've also got some stuff like this known as assessing and interpreting faults.
Mm-hmm. Okay.
That's the second subject. In here, the third one will be describing the causes of faults.
Causes of
I
faults.
mean,
Okay.
we're gonna look for the reasons. Why did
Mhm.
this happen? Why the machine didn't function? Why this? Okay.
Why is the root cause? The root
Mm-hmm.
cause in this case.
Exactly.
Mm-hmm.
And how can we change it? And the last topic, the last subject or section is discussing repairs and maintenance. Now that we identify the problem, then, well, how can we fix it? How can we change that problem into a solution, a possible and efficient solution? Okay, that's the content that we will be working during this unit, Unit 5, Breaking Point. So the first part, it's titled Describing Types of Technical Problems. This is included technical problems. So before we begin talking about technical problems, let's have a background information. We know that cars are used. Okay, we
Mm-hmm.
use cars all days. We use cars in all the
Yeah.
sectors, in other work areas, machines, and stuff like that.
Mm-hmm.
So, for this section on technical problems, we might talk about motor vehicles and the problems that can occur with them represent an area that should be familiar to students, in this case to engineers, for
Mm-hmm.
their general technical knowledge. The
Mm-hmm.
specific terms for car parts are covered in order to prepare students for the motor racing context.
Mm-hmm.
That's also important. We're going to talk about the motor racing context,
Okay.
vehicles in motor racing context, which
Okay.
is used to exemplify the main target language of this unit.
Okay. When you talk about more racing context, you are talking with cars with high speed. I mean,
Exactly, like Formula
okay.
One, NAFTA, and stuff like that.
All right. All right.
And well, it should be noted that the target language that we're going to work like verbs and adjective, it's used to describe the technical problems. So we might look at them during the section and is relevant to all the main fields of engineering. Okay. Maybe it's not as structural engineering, civil engineering, but this language help in technical general knowledge.
Okay.
And well,
Good.
during this section, you will find useful the next language. Words such as abrasion, heat, pressure, you might remember these words from the unit 2. Physical shock, vibration, bend, block, blow up, clock, that means to go up, cut out, jam, leak, run out, snap, whir, and work loose. This vocabulary will be used during this first section.
Excellent, excellent.
Mhm.
Okay.
And well, as I was saying before we begin, I want you to give me a little description, a short description of a technical problem.
Yes.
Maybe I recently experienced at work, at home, a technical problem.
Okay. Well, I can explain about several technical problems, but I
Mm-hmm.
think in engines of cars,
Okay.
maybe when the engine exhaust with exhaust black smoke, uh, I mean with engine has a oil leak, the oil leak or oil leak.
How to
Mm,
oil it? Mm-hmm.
yes. Um, I can describe some failures like a noise in the
Okay,
engine,
did not. Okay.
uh, and when the engine did not start,
Okay.
I can start when I cannot. Uh, well, one more. Well, maybe that examples is very common in the cars, no? But
Mm-hmm.
in the cars, well, it could be a good system. Is very difficult in occasions, and I can describe those like problems. I mean, of maintenance or problems of operation.
Mm-hmm.
But it's interesting. When I talk about cars, well, the experience is important. No, uh,
Okay.
I think like that. No.
Mm-hmm.
Mhm.
Yes, as another example, and actually it's a really recently experience.
Okay,
Um, I do have a Dell projector
gel
to
projector.
watch movies,
Okay, yes.
presentations, and stuff like that. I have one of them.
Uh-huh.
But I didn't use it all last year because
Mhm.
of the coronavirus and stuff like that.
Exactly.
I didn't use it, so it was just staring there and there and there.
Mhm.
Suddenly, like some weeks before, I wanted to watch a movie, and I said, okay, I'm gonna use my projector.
Mhm.
Uh, but after 5-10 minutes that it was turned on, um, the picture of the projector start turning in colors like blue, red, orange, green, blue, red, orange, and then boom, it sounds turned off and it smells like smoke. And the temperature sensor in the projector was turned on. And I was like, okay,
Mhm.
I don't know why this happened. It didn't happen
Mhm.
before. So this is a technical problem that happened to me. What did I did? Well, last week I
Uh-huh.
sent it to the technicians and stuff like that,
Mhm.
and they give it to me today. Actually, today morning,
Mhm.
I take the projector with me, and it looks like new. And well, the fault wasn't here
Mhm.
the wheel
All right.
color, and the photo sensor.
Mhm.
And I was looking at the piece and stuff that.
Yeah, yeah.
So that was another example of a technical problem
Mhm.
that I
Mhm.
experiencing here at home. So yes, during this part, a breaking point, it's known because it's the limit. You might remember that last unit, we were working with something that was known as tolerance,
Yes.
tight tolerance. So
Tolerance, accurate,
a tight
etc.
tolerance makes
Uh-huh.
reference to the limit of
Yeah.
something, the limit that a piece, a machine, a process, or a system can have in order to do something.
Mm-hmm,
Okay,
mm-hmm.
you might remember the centimeters or millimeters from a piece. Like
Yes, yes, yes.
it can have a tolerance of 3 millimeters from
Mm-hmm.
103 to 97. That's the
Mm-hmm.
tolerance.
Mm-hmm.
So in this case, it's a little bit connected because the tight tolerance gives us the limit of something. So in this case, a breaking point is that it's the limit of something before something, in this case, goes to something bad.
Okay.
Okay,
Okay.
the breaking point
Uh-huh.
is when it happens, or the limit before something bad happens in my system, in my process, in my manufacturing, in my machine, whatever.
Okay.
And well, in this case, we're
Good.
talking about cars. Mhm.
Mhm.
Great. So in your book, you might see this picture, breaking point. We have the picture of two cars actually from Formula One cars.
Yep.
So
Yes. This is.
which challenges, and that's my question, which challenges,
Uh-huh.
problems, issues do you think the car races like the
Uh-huh.
Le Mans 24 sport
Okay.
cars need? I mean, we all know daily cars like the Ubers, like our own cars, and stuff like that. But what happened with the race
Mhm.
cars? I mean, what's the problem? What's the like the technical challenge that the race cars need to function
Okay.
in 100% of efficiency?
Mm, okay.
What
Uh,
challenges do you think might happen or might affront the engineers of racing cars?
well, I think it's necessary that car is working in one race. In a one race, I mean,
Mhm,
is the car has to be in working condition, in a good working condition.
mhm,
Uh, Maybe I have to. Well, I think the engineer should be and or should be con- concentrate in problems, in technical problems, or try to avoid technical problems in the cars.
uh-huh.
I think it refers like wears or fractures in the material of the different components, etc. No,
For
I think so.
example, two
Mhm.
let's say like big challenges or obvious
Okay.
challenges in a racing car
Mhm.
must be the engine and the tires, because the
Okay.
engine gives the power to the car. So we're not
Mhm.
talking about an Aveo motor engine or
Uh-huh.
stuff like that. We're using real power engines in these racing cars.
So,
And of course, the tires is also a challenge, because if you have seen the tires of the Formula One racing cars, they are small, but they are not thin. They are thick.
uh-huh.
So this it's a challenge. As an engineer, talking about specifically about racing cars, you need to know what material, what process you need to have in your car in order to have a real good and optimal efficiency. Mhm. So that's the main point in here. So
Mhm.
we have three questions. You might
Okay.
see them in number two. Let me just make a small zoom.
Okay. It's okay.
So Sabino, Sabino
So,
is an engineer. Okay, he's an engineer with a
okay.
sports
That.
car racing team. So he has a racing team, and he is giving a talk to some of his team's sponsors at a
Oh,
test session. So remember, a sponsor, it's a company or a person who, in this case, give money or invest money in that team or in that person or in that project, like a Shark Tank.
it could be in
Okay.
Spanish like patrocinador or.
Exactly. That's a sponsor,
Mhm.
patrocinador.
Ah, okay.
So the sponsors are looking at the car in a test session. I mean, they're looking if the car is in a good work condition, optimal customs and stuff like that. And Sabino is talking to them about some, well, actually are the questions. Sabino is talking with them about some issues.
Okay.
Could you please read the three questions?
Yes. Number one is what saying emphasizes the importance of reliability. Two, what expression refers to things that can cause failures? And number three, what expression describe damage caused by normal use? Okay.
So
Okay.
we're gonna have a conversation, of course, of Sabino with the sponsors team. And the first questions makes reference to the importance of reliability. You know, reliability, it's like the, let's say, confianza. Okay.
Yep.
So what's
confianza.
What saying emphasizes the importance of reliability? What saying? That means que dicho, que frase. Something that he will say talks a lot about reliability and its importance. The second questions, it says what expression refers to things that can cause failures. You know, failure, it's like a problem, something that needs to be fixed. So, well, he mentioned some things again. What expression that he said makes reference to that. And the third one, it's what expression now describes damage caused by normal use. No, maybe not a technical problem, but something because of the use of that. Okay, so let's listen to the conversation. Okay, what Sabino is telling to his team. It's a short listening of 1 minute. So listen carefully.
5.1 A race is not just a test of speed, but the ultimate test of reliability. There's an old saying, to finish first, first you must finish. And it's especially true in endurance racing. You're not just competing against rival teams, you're also fighting what you could call engineering enemies, which can cause parts of the car to fail. Things like heat, pressure, vibration, shocks, abrasion. There's continual stress on almost all the components, all the nuts and bolts on the car. The chassis, engine, gearbox and clutch, suspension, brakes, tires, wings, cooling system, they all have to cope with phenomenal levels of wear and tear.
Okay. So, I'm going to play it again, but now I want you to go to your book on page 89. Okay, go to your book, page 89.
89. 89.
And we're gonna look for 5.1. It's a page like this, 89, and you're gonna look. Yes.
Okay, Sabino, yes.
Sabino. Yes. So listen and read.
5.1.
Okay.
5.
Oh, there
5.1. A race is not just a test of speed, but the ultimate test of reliability. There's an old saying, to finish first, first you must finish. And it's especially true in endurance racing. You're not just competing against rival teams, you're also fighting what you could call engineering enemies, which can cause parts of the car to fail. Things like heat, pressure, vibration, shocks, abrasion. There's continual stress on almost all the components, all the nuts and bolts on the car. The chassis, engine, gearbox and clutch, suspension, brakes, tires, wings, cooling system, they all have to cope with phenomenal levels of wear and tear.
Good.
Okay.
Okay, let me read.
Mhm.
5.1, Sabino, a race is not just a test of speed, but the ultimate test of reliability. There is an old saying, to finish first you must finish, and it's especially true in endurance racing. You are not just competing against rivals teams, you are also fighting what you could call engineering enemies, which can use parts of the car to fail. Things like heat, pressure, vibration, shocks, abrasions. There is continuous stress on almost all the components, all the nuts and bolts on the car, the chassis, engine, gearbox and clutch, suspension, brakes, tires, wings, cooling system, they all have to cope with the phenomenal levels of wear and tear. Okay, good, very good.
Exactly. Mhm. So using that reading and that listening, we must answer now the questions in here. What saying, that
Okay,
means que dicho, what saying emphasizes
okay,
importance of reliability?
okay.
And
In
it
this
comes at
case,
the beginning.
mhm, mhm. He say about the ultimate state of reliability,
Mhm.
uh, like that, like to finish first you must finish.
Exactly.
That's all, right? Seems like that's all.
That's the saying, ese es el dicho. To finish first,
Okay, that's the same.
first
Okay.
you must
First,
finish.
you must finish. Yes, it's the objective
Okay.
or challenge in the
Exactly.
racing team. Okay.
Then the second question asks us to the expression that refers to things that can cause failures. I mean, he says something, he like a phrase of something that make reference
Mhm.
to failures.
Okay.
Which
Mm.
phrase is it?
He mentioned about the when they're fighting what you call engineered enemies, which
Exactly.
can cause parts. Yes, of the cars. Okay.
Engineering enemies.
Mhm.
Okay, because sometimes instead of looking at the other team as a rival or a competence or something like that, you might see them as engineering enemies because all the teams do engineering. They are sending their best cars, their best engines, their best racing team in engineering. So you are not just like doing a competence with cars, but you're doing also a competence in
Mhm.
engineering.
Okay, okay. Yes, he mentioned about phenomenal levels of the word and tear, no? Word and
Exactly.
tear.
Word and tier. That's the expression that he uses to talk about a normal cost, well, a normal use damage.
Ah, okay.
Okay,
Okay.
perfect. You might write next to the questions if the answer.
Okay.
Tell me when you're able to erase it.
Mhm. Well, the letter B is
Mhm.
5.1 in the talk. Sabino names 5 engineering enemies and complete the following list. Listen again and check your answer. Okay.
Okay. During the
Okay.
listening, Sabina mentioned the engineering enemies. You might
Yeah.
remember them as, let's say, automotive parts.
Yes, 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 yes.
So we have the first letter HPVSA of the
Okay.
component and, well, the definition or the meaning of this. So for example, when we talk about the high temperatures,
Uh-huh.
that makes reference to
High temperatures. Highest? No. No, 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 no. Okay. Heat.
Head, exactly.
Right. Okay.
Head.
It's
Number 2, loads from
Loads.
expanding gases or liquids. And it starts with P.
Yes. High loads. No, it's not high loads from spinning gases of liquids.
When we talk about gases and liquids.
The oil or the oil as peaks. No, is like pressures.
Pressure, right? Exactly. Pressure. Pressure. There it is. Okay. Excellent. Then the third one.
Okay.
It's with V, and it says that continuous high frequency of movement or shaking. Something continuous.
It's not breaks. It's just. Continuous high frequency movement or shaking versus vibrations.
Exactly. Vibration. So we read vibration. Number 4, we talk about sudden impacts.
Sudden impacts, okay. In this case, impacts is it could be like impacts. Synonym to impacts is like shocks.
Shocks, exactly. Shocks.
Yep.
And number 5.
Damage. Damage to surface caused by friction is not abrasive or no?
Abrasion.
Abrasion, okay.
Abrasion, yes. Okay. Perfect.
Yes, it's good.
May I erase it?
Yes. Thank you.
Okay. You're welcome. So, if we go just a little bit down below, it says, impair suggests which engineering enemies in exercise 2B can be the most problematic for each of the following card parts. We have 9 car parts in here. The chassis, the engine, the gearbox and clutch, the suspension, the brakes, the tires, the wings, the cooling system, and nuts and bolts. So we know the 5 enemies. The 5 enemies are these ones.
Yes. It mentioned
we know
5 enemies. Yes.
The heat, the pressure, the vibration, the shock, and the abrasion. So from these 5 enemies, which one affects more to the chassis?
Fractures is not here, right? No.
So if we think about the chassis, which one is one of the most common enemies? Maybe the heat, maybe the pressure, the vibration.
Shocks.
Okay, shocks is something really common that happens in the chassis.
Where
maybe you can write next to the word like the enemy, like in parentheses, so that you remember it. Then in number 2, it's the engine. From the 5 enemies, which one damage more the engine, or it's more common to have?
It will be abrasion.
Abrasion in the engine. Okay. Why not? Yes. Also heat, maybe.
Maybe yes.
Because of the engine, yes. What about the gearbox and the clutch?
Clutch.
Gearbox and clutch. Which one?
Abrasion.
Abrasion, yes. That's one of the most common. Number 4, we talk about the suspension. Which one would be the most common enemy for the suspension?
Vibration, shocks.
Shocks too. And what about brakes?
Brakes is common like abrasion.
Abrasion,
So,
yes, exactly, because of the friction.
yes, it's like similar to the clutch or
Mhm.
the tires
And
is the same. The tires, the number
the
6 is
tires, yes,
abrasion.
abrasion, the same, yes, because of the friction with the floor, with the
Yeah.
pavement. And what about number 7, the wings?
Okay, wings. Could you explain a little bit about wings? I don't remember that
The wings
technical term.
actually, it's specific to the racing cars. For example, the aerodynamic.
Okay.
Uh-huh.
Okay.
No wings like the birds. No, no, not
No,
that
no,
kind
no,
of
no, no,
wings.
no, no. Yes. So aerodynamic. Yes.
Actually, we're gonna have an extension activity like next of this exercise, and I'm gonna explain all these parts.
Okay. Good.
Mhm.
Well, wings is could be fractures. No. Maybe impacts. No.
Some sudden impacts maybe because of
Impacts. Okay.
a rock or
Okay.
something. So some shocks would be.
Okay. Shocks. Yes.
Then we have the cooling system.
Cooling system. Well, the cooling system is by high temperature
High
or
temperature,
heat.
yes. The pressure, the heat.
Yes. The
Mhm.
pressure too. Yes.
And finally, nuts and bolts.
Symbols. There, we get we can get fracture in well impacts.
What else?
Vibrations.
Exactly. The vibration affects a lot the nuts and bolts. Because if it vibrates a lot, then the nuts and bolts might fracture or
Yes,
might disassemble or something like that.
exactly. Yes.
In some drastic cases.
Okay.
So as I was telling you, let's go now to, well, we don't have this extension activity print. When you have it, you're gonna read and you're gonna answer the questions 1 through 6 if they are true or false.
There's
Okay.
trees, and then the extension activity trees or
Yes, there are
that
trees.
says
It's because this is a picture, it's a map of
it's a
the
map.
racing
Oh, all
race
right.
in Le Mars.
Okay. Good.
Well, I'm gonna explain this extension activity. I mean, it's actually easy. I think it's not difficult.
No,
The extension
I don't think so.
activity, it's gonna talk about the automotive parts. So the ones that we just watched in this exercise. So we have these
Alright.
5 parts of a car,
Chassis,
and we have
engine.
to take out the meaning, the
Okay.
definition of these words.
Okay.
Mhm.
Well, in this case, chassis is the escalates of the cars or the structure, main structure of the cars.
Mhm.
One more chassis. It's one structure of metal that is the component, the principal component of the cars.
Mhm. Is a
And
piece that supports.
okay. Is that
So we can
works? Okay.
say that a chassis is the load-bearing framework of an artificial object, which structurally supports the object in its construction and function.
Good.
Mhm.
Okay.
That's like the good definition for chassis. Then we have engine.
Engine is a combustion engine or of 4 times in this case with 4 times like a power the car is
Mhm.
powered of the car is the I mean the source of the car or
Okay, the energy source.
energy source of the car. Yes.
So that means it's a machine
Yes,
designed to
so-
convert one form of energy
Think so.
into mechanical. And we mean mechanical because we need to move something. In this case, a
Okay.
car.
Mhm.
Then we go to the gearbox.
Gearbox. Well, the gearbox is the component for the the principal or the main component where the car control the speed and control the speed
Acceleration, maybe?
and accelerations. Well, in base, all in base of the
Mhm.
high speed and low speed. Control that kinds of levels
Yes,
acceleration, no, for acceleration.
exactly. So the gearbox is a machine in a power transmission system which
Mhm.
provides control application of power.
Okay.
Then we go with the clutch.
Clutch, well, is clutch is I mean, it's like a shoes. Is necessary to apply a ration for the transmit power, where it can transmit power about to some shoes or
Mhm. Okay. The book defines it as a mechanical device that engage and disengage power transmission, especially
Okay.
from a drive shaft.
Okay.
And the last one in here is suspension.
Suspension is necessary for absorb vibrations in the structures of the car.
Mhm.
Maybe it can be like maybe components with gas or
Mhm.
air, like that, no?
Mhm. The book says that, well, it's a system of components allowing a machine, normally a vehicle, to move smoothly with reduced
Okay,
shock.
okay,
And, well, we also have these force. You're gonna help me reading the meaning of these parts.
okay. Brakes. In this
Mhm.
case, brakes is a necessary system for the stop the car. And they brakes allow to get high temperatures if the car is operating normal with the normal situations. Uh, in base to the shoes or parts, mechanical parts.
Mhm.
Okay.
So could you please read it?
It's a mechanical devices that inhibits motion by absorbing energy from a moving system. Okay. Okay.
Exactly. Then we have the tires.
Well, in this case, tires is the wheels.
Yes, it's another name
Are
to that
can
word.
travel of the way or road and absorb vibration or abnormalities in the way, no, or the road. And these components
Mhm.
are of the rubber or with air or nitro, and it depends of vehicle. Everything is a good element, no, of wear in the car, no?
Mhm. Okay, so in this case,
Tires.
well, it says
It's a ring shaped component that surrounds wheels rim to transfer a vehicle's load from the axle through the wheel to the ground and to provide traction. Traction is important. Provide traction. Yes. Yes.
Then we have the
Good.
wings.
The wings
When we
was
talk about aerodynamic parts,
aerodynamic parts.
a meaning for this one is this.
It's a type of fin, okay, that produce lift while moving through air or some other fluid. Okay, good.
And well, the last one is a cooling system.
Cooling system, the system is trying to reduce the high temperature or high temperatures or levels very high or where the engine try to support all the loads in the car, no? And I think it's the good system in that part.
Yes. And well, in this case,
Uses either air or liquid to remove the waste head, okay, from an internal combustion engine. Okay, yes. Good.
exactly.
Mhm.
Perfect. Thank you. So let me go. Okay. In this part in here, let me just go back to the book.
Okay.
Here it is.
Good.
So it says in here, exercise 3A. Listen to Sabino talking about some technical problems to the team that the team have had at the test, and mark the following statements if they're true or false.
Okay.
Okay.
Good.
So let's listen to Sabino and the problems.
Okay.
And you will tell me if they're true or false.
Yes.
Listen.
Number one is
yes.
some. Okay. Number one is some liquid was lost from a pipe, right? Number two is a car lost all its coolant with the engine still running. Number three is a car's engine stopped on the circuit. Number four is some tires were damaged. Okay. Number five is a wheel not fell off a car on the circuit. And number six, a car's suspension was broken. Good.
So listen carefully to the conversation. This is a 2 minutes conversation.
Okay.
Listen carefully.
2. Just to give you some examples of the types of technical problems we've had so far at this test. On one of the cars, a nut worked loose on a radiator pipe, which resulted in coolant liquid leaking out. That caused the engine to start overheating. Fortunately, the driver saw the warning light come on and he switched off before the system had run out of coolant. Then, on the other car, we had a fuel feed problem. The engine cut out on one of the corners. That caused the driver to spin off. We were fortunate he didn't hit anything. But when the car goes off the circuit, the openings in the side pods always clog up with dirt. So those had to be cleaned out. Obviously, you don't want anything blocking the airflow to the radiators. And then, because of the spin, the rubber was flat-spotted. The tires weren't close to wearing out, but they still had to be changed because of the flat spots. And then, while they were putting the wheels back on after that, they had a wheel nut jam. It wouldn't turn. And that's actually how problems tend to happen. Very often, you get a kind of chain of events when you feel that everything's going against you. Having said that, you could also say we were lucky. Fortunately, the radiator problem didn't cause the engine to blow up. And after the spin, luckily he didn't hit the barriers and bend the suspension or snap it completely. And even more fortunately, it didn't crack the tub, the chassis.
Okay. Now I'm gonna play it again. Now you can go to the book on page 89 again, so that you can read the conversation at the same time that you listen. Okay. That it's in here.